Recording in progress.
Alright, hello everyone. So today I'm going to discuss about the stochastic calculus computer-based test for the question 4 and question 7. So now first we are looking at the question 4. So we can see that this is a put on call option, and then there are the following information given, which is the risk-free rate, the dividends, and the underlying option, the compound option, and so on. So now we want to calculate this question by using the Excel. Okay, first we need to apply all the parameters, which is the R is the risk-free rate, which is 0.07, and then the delta is the dividend rate is 2%, and then the strike price of the underlying option is 49, the strike price of the compound option is 4, and then the T is the 24 periods, yeah, which is the stock price of the binomial models is 24, and then the another T is the 12, which is the underlying option expires 1 year after the compound option. Yeah, so which means there's only 12 months. And then the sigma is 0.2, which is the volatility of the stock. And then the current stock price is 51. And then we need to compute the H, U, D, and the P star to calculate the binomial trees. So the H is 1 over 12. And then the U, okay, so the U, the formula is the exponential of R minus delta times the H plus sigma times the uh, square root of H. So we can compute the U, and then the D is same as the U, just the difference is the between is minus. Yeah. And then we can compute the P star. So the P star is the exponential of the R minus delta times with the H, and then minus D divided by U minus D. Yeah, so we can get the P stars. So after getting all the parameters, we want to calculate the stock price. So we know that the stock price given is 51, and then calculate by using binomial tree. So we need to set up the 24 period, and then for each period we need to calculate the SU and SD. Yeah, so I'm using the Excel formula, which is I set up it as if the B16, yeah, this one is blank, so it will be the review. If it is true, then if B15 is also blank, so it will be blank. Otherwise, the B15 will time the value in B15 will times with the D. If the B16 is not blank, yeah, which the column have the value, so if you times with the U, so for this value, if you become B16 times with U, yeah, so if you get SU, and then for this one we'll get SD. Since B17 is blank, yeah, so we will look at B16. So it's B16 times with the D. So this one is a SD. Yeah. So and then straight away continue to compute all the value. Yeah, until the period 24. Alright, after that we need to find the underlying core. Yeah. Since underlying call is will expire 1 year after compound option, so means that we need the call is in our hand for 2 years. Yeah, so we need to find 24 period. So when finding our call, we start at the last period. So to find the call price, we need to use the formula, which is the S minus K. Yeah. So for this one, we use if the ST is bigger than the K, the underlying K, so we will take the ST minus the underlying K. Otherwise, the value will become 0. Yeah, so the last period of call price is using this formula to calculate it. And then to calculate the previous call price, so we same as we also need to use the Excel formula. So since this is the American call option, so we also need to compare which call price is higher. Is the CU higher or just the using the stock price minus K of the call price is higher? Yeah, we need to compare the stock price minus K of the call price is higher or the by using the CUCD. Yeah. So here we insert that if the Z43 is blank, so it will be blank. Okay. Otherwise, we will take it by using the CU. So which is the formula is exponential minus RH times with the P star times with Z42, which is CU, plus 1 minus P star, which is the Q star, times with Z43, which is the CD. Yeah. Or otherwise, we will be taking the the ST minus K. Yeah. We we need to compare which value is higher. So this is the method of calculating the underlying call. After that, we need to compute the compound put. Since the compound put is expires in 1 year, so it is just from 0 until the 12 periods. Yeah, it's until 12 periods. So yeah, same as the call, we need to find the put price from the last period first. So to find the put price, the K should bigger than the ST. So if the K bigger than ST, we will take the K minus ST. Otherwise, we will make it as 0. Yeah, won't be negative value. So just compute with the formula and then drag down. After that, yeah, we need to compute the previous period of the put price. So if the if the the PD is blank, so we'll let it blank. Otherwise, we'll use uh, the put price formula, which is the P star times with the PU. Yeah, the put U are the put upper price plus with the Q star times with the put under price, and then times with the exponential negative RH. Yeah, we will take the value. Okay, so after finish computing the value, we can get the P at the period of 0. Yeah. So the P0 with the price of put on call, which is 0.554444744. Yeah, this is our question 4 answer. So next, we are looking for question number 7. Okay, so in question number 7, we are given that the person Tamara Melon is the London-based fashion designer is expecting to receive the 100 million yen from a Japanese company. Yeah, so now we expect we are the England, yeah, the England person. So our domestic is pound. Okay, our domestic is pound. And then the question asks us to find the cost of hedging using the binomial tree method, yeah, which has the 12 period using the two distinct approach is pound denominate and yen denominate. So now first we need to find the pound denominate first. So we are based on the pound. So now our domestic is the pound. So we are given that the spot expenditure is 0.05 pound is equals to 1 yen. Yeah, so now x0 is 0.05 and then the k is the 0.005 and then the volatility exchange rate is 0.08 and then for this part we need to pay attention because there are two kinds of rate. So for this the rate of domestic is 0.035 and then for foreign rate is 0.055. Yeah, because now we are the England person, so our domestic is pound. So after that, for calculating the binomial tree, we also need to find H, U, D, and P star. Yeah, same. For H is 1 over 12, and then the U formula is the exponential R minus delta times H plus plus the sigma times the square root of H. Yeah, and then for D, it's just different with here is the minus. Okay, so for P star formula is the exponential of R minus delta times H minus D divided by U minus D. Yeah, so we can calculate the P star. Okay, so first we need to calculate the exchange rate. So for this part, it is actually sent as the calculated stock price. So we need to compute the SU and SD. So also using the Excel formula, yeah, which is if the B15 is blank, so we will get the next value. So we'll see, look at if B14 is blank, then we'll leave it blank. Yeah. Otherwise, we will use B14 times with the D. So you can see that here, B15 got the value. So we will use this formula. Is B15 times with the U. So this value is the SU. And then this one is SD. Yeah. And then continue to calculate until the period 12. So after that, we will get the put price. So put price, which is the K should bigger than the ST. So if K bigger than ST, the K will minus the ST, otherwise the value will be 0. Yeah, and then for finding the put price, so we need to compute the formula, which is the P star times with the N29, which is the PU So plus with the Q star times PD, n to the d is PD, and then times with the exponential of negative RH. Yeah. And then just calculate until the period which is the current period. So we will get a value which is 0.00592,163. So now we can get our cost of hedging. But remember, today we are going to receive the 100 million of yen. This value is just for the 1 yen. Yeah, so we need to time with the 100 million. So we will get the cost of hedging, which is 59,216 and then 0.29285. Yeah, this is the cost of hedging. So now we change our characters. So we become the Japanese, and then our currency rate is yen. So for the x0, because we are given that this is under pound, so we need to change it to yen. So we need to 1 over 0.05. Same as the k, also need to change it under yen. So we need to use 1 divided by the k in pound. And then for the sigma, yeah, the rate is still the same. And then for this part, we need to pay attention because now the rate of domestic is yen already. So here the rate of domestic and rate of the foreign is different. So the HUDP star all will be different. Yeah, but the method still the same, just the value is different. Okay, so after that, same as to find the exchange rate in the pound denominator. So yeah, the formula is all the same, is finding the SUSD. Okay, but here we are using the call because uh here we are the person who have the right to buy, so we need to use the apply the call option. In pound is the right person or to sell, so it is apply the put option. Yeah, so for this part need to pay attention. This is the call option. Okay, so finding the call option, yeah, here is different with the put. So which is the ST should be bigger than the K, otherwise the value will be 0. Yeah. And then for this part, it's still the same method to find the call price, the CUCB. Yeah. Okay, after calculating the call price, so we will get our cost hedging. But for here, since this is the since we know, right, the K is 1 at 1.1 which is the 181 yen is equals to 1 pound. So we need to find the cost of hedging under the pounds. So we need to take the 100 million yen divided by the K and then times with the call price, the current call price. So we will get the cost of hedging, yeah, in pound. Okay, if you want to check the answer is correct or not, you just use the cost of hedging of the yen denominator and then times with the x0 of the pound denominator. And then you will get the same answer with the cost of hedging in the pound denominator. Yeah, so the answer will be correct. Okay, so next we look at the part B. The part B is asked us to calculate the price of option by conducting the Monte Carlo simulation of the 100,000 iteration using the Excel. So I'm using the put option. So using the pound denominator. So for the order rate is using the power denominator one. And then for here, I'm creating the 100,000 of the uniform distribution value, yeah, by using the random. So the Excel will give me the 100,000 of value. After that, we'll find the z-score. So to find z-score, we are using the formula is the standard normal distribution, the inverse value. Yeah, so inverse value. And then after that, for the exchange rate, okay, exchange rate is using the X is same like the Black-Scholes model. So is the X naught times with the exponential of the R minus RF minus the 0.5 of sigma square times with T minus T. And then plus the sigma times with the square root of T minus T and then times with the z-score. Yeah, we will get the exchange rate. Okay, so after that, the pair of, since this is the put option, so the K should bigger than the exchange rate. Otherwise, the value will be 0. So here we use the maximum, the K minus exchange rate. Yeah. So if the K minus the exchange rate is negative value, so it will become 0. Yeah. And then after that, finding all the values, we need to compute the expected pair off, which is the average of the pair off. Okay, and then after that, we compute the price of auction, which is use the expected of payoff times with the exponential negative R domestic times with the T minus T. And then don't forget to times with the 100 million of yen. Yeah, because here we got 100 million of yen, not 1 yen. So we will get the final answer, which is the price option equals to 59,312.7218. Yeah, so this is the answer for the question 7. And yeah, this is the end of my part. So thank you for listening my sharing. So see you next time. Bye bye.